All right, we got another pretty challenging functions question coming your way from an old IBHL exam. Let's jump right into it. We have two functions, f and g. F is defined by 2x plus pi over 5, where x is defined for all real numbers. And g is 3 sine x plus 4, also x defined for all real numbers. Part A of this question, let's jump right into it, is we have to show for 1 point only, to keep in mind, that the composite function g of x is 3 sine of 2x plus 5 over 5 plus 4. Should be pretty straightforward. Remember that a g of f of x, a composite function, we can rewrite this as the g of f of x. In other words, we're going to take the f of x function and plug it into the g of function, and that should give us exactly the given function in the problem statement. So let's have a look. I'm going to rewrite this now as g of, and then I'm going to put in the f of x function right here, 2x plus pi over 5. And from here, I'm just going to plug in a 2x plus pi over 5 for x, or substitute for x, in the g of x function. So that gives us 3 times the sine of, open parentheses, 2x plus pi over 5. The 4 is kind of chilling on the outside. That is exactly the same thing that we were asked to show, so that is 1 mark. For part B for this one, we're asked to find the range of the composite function g of f for 2 marks. Now, some of you may think, ooh, I can use some cool properties or the properties that I know about composite functions and try to figure that out. For this one, actually, the best thing to do is just remember some nice, decent properties for the sine, cosine, the trig properties. So that's technically trig unit, not necessarily functions. We'll get to the trig stuff in a later series, but for the time being, let's start to incorporate that all together. So let's look at this composite function. I'm going to switch to yellow. Looking at this, right? We know that a sine can have a maximum value of 1 and a minimum value of -1. Right? The sine function takes in all these different angles and it oscillates between 1 and -1. So the absolute highest number that it can be is a 1. So what happens if I plug in 1 in for sine? I would have 3 times 1 plus 4 is going to give me 7. That's the highest possible value that g of f of x function can take on. And similarly, if I plug in a -1, what do I get? I get 3 times 1 is -1 is -3, plus 4 gives me 1. So the range of values that are kind of feasible, that are okay for this function, y, is all the numbers between, in this case, 1 and 7, inclusive. So I should be putting square brackets here to show that y is going to be all values between 1 and 7. Oh, it's not even in frame. Let's fix that. Y is all values between 1 and 7. There we go. There's the range for this composite function. Part C. Part C is also a little bit trig and not as much function stuff, but we're still going to do it anyway for the sake of completion. All right, let's get to it. Problem statement reads, given that the g of f of x evaluated at 3 pi over 20 is equal to 7, find the next value of x greater than 3 pi over 2 or 20 for which that same condition holds true. Okay, something we immediately notice here is that 7 is really, really important. Remember what we just did in part B. The range for this function is 1 to 7. 7 is the absolute highest value this function can take on. And we know that's only going to happen when the sine of whatever angle or whatever variable is being evaluated is equal to 1. That's going to be really important for us. So let's look at this equation. We know that when we're evaluating that composite function at 30 pi over 20, that's giving us 7. That means that 2x plus pi over 5, the inside of the sine curve, has to be equal to pi over 2. Pi over 2, because pi over 2, remember, is 90 degrees. So we're going to use our fundamental understanding of trig to know that sine of 90 degrees, or the sine of pi over 2, is equal to 1. That's the angle with which sine is maximized. But remember, if we think about the unit circle, that pi over 2, or that sine of 1 happens every 360 degrees. So every single time we'd rotate 360 degrees across that unit circle, or if we remember in radians, every time we rotate 2 pi revolutions across the unit circle, we're going to get back to that pi over 2 mark. So our sine function is again going to go from 1 down to -1, back up to 1, so on and so forth. I'm going to write this though, I'm going to underline. So we're going to take pi over 2, add every time we do one revolution around the circle, where the n is the number of revolutions, there we go, we're back to that pi over 2 relative angle or sine of 1 mark. To solve this, we're just going to algebraically manipulate this equation and solve for x. That's it, just like you've been doing since you were about 12 years old. So to do this first, I'm going to rewrite the fractions as both with denominators of 10, a common denominator, 5 pi over 10, and for the time being, I'm just going to leave this as 2 pi. So I'm going to essentially set, if we do this in yellow actually, let n equals 1, we're going to go 1 revolution over. Just for the time being, it makes our lives a little bit easier, but you can leave the n in, it's also fine. Back to pink. Now we can combine those like terms. So we'll have 2x is equal to 3 pi over 10 plus 2 pi. Then if we divide everything by 2 to leave the x by itself, so get rid of that coefficient, we will have 3 pi over 20 plus pi. Now, remember that n is technically still hidden in here, which means that every time we go n pi's, or 1 pi, 2 pi, 3 pi's, n is just taking on an integer value here. Every time we go n pi's along the unit circle, this is telling us that that sine value evaluated at that x coordinate is going to give us a total sine value of 1. Notice here also, if this 3 pi over 20 we're pretty happy with, because that happens to be the exact same value that we were fed in the earlier part of the problem statement. So it was kind of a given. But the nice thing is that we know now is that the next point is going to be pi units above that. So pi units, if we take 3 pi over 20 and we add pi units to it, well, we can rewrite pi as a fraction, 20 pi over 20. That way they have the same denominator. So 20 pi over 20 gives us 23 pi over 20. And that is going to be the next x value that we can plug in to this composite function that will give us a total value of 7. Let me rewrite this up here. 23 pi over 20 is the next x value.